Hello, so in the last few classes we were looking into distribution problems. So we have seen the ways of distributing objects to distinct boxes. So your objects can be either identical or they can be distinct objects. So in today's class we will look into a problem of distributing distinct objects into identical boxes. So we will see the problem of distributing distinct object to identical boxes, and this gives rise to a set of numbers called, so that is called as the Stirling number of second kind. So Stirling number of second kind is associated with distribution of distinct objects to identical boxes. So we have seen Stirling's number of first kind. So that is the number of ways of arranging objects along indistinguishable circles such that each circle contains at least one object. So same way here we will define the Stirling number of second kind. So it is usually denoted by, capital S of Rn. For Stirling number of first kind we use the notation small s of Rn. So S of Rn is defined as the number of ways of distributing are distinct objects into n identical boxes such that no box is empty. So that is the definition of the Stirling number of second kind. So S of Rn is defined as the number of ways of distributing our distinct objects into n identical boxes such that no box is empty. So some of the results satisfied by S of Rn. So first result is, so S of 0, 0 is equal to 1. So this is like a convention. So we are defining S of 0, 0 to be 1. So this is the case when you have 0 objects in 0 boxes. So when the number of objects and number of boxes are the same, there is just one way to distribute. So this is more or less a convention. So S of 0, 0 is equal to 1, and the second result is S of R0. So this is the number of ways of distributing R objects to 0 boxes. So, and again distributing 0 objects to n boxes. So both of these are 0 for all R comma n belongs to n. So S of R0 and S of 0n will be equal to 0. And the third result is, so S of Rn will be greater than 0 if you have R greater than or equal to n greater than or equal to 1. So if the number of objects are more than the number of boxes, so each box must be non-empty. So that will be always possible in this case because the number of objects is more than the number of boxes. So in this case S of Rn will be always greater than 0. And again S of Rn will be equal to 0 if n greater than r greater than or equal to 1. So if the number of boxes is more than the number of objects, so in that case you will have some of the objects to be empty. So in that case S of Rn will be equal to 0 because you are finding the number of ways of distribution in which all the boxes are non-empty. So S of Rn will be equal to 0 when n is greater than r. So the fifth result is if you take S of R1, S of R1 will be, this is the number of ways of distributing R objects to one box. So that means all the objects will go to that single box. So this can be done only in a single way. So S of R1 will be equal to 1 for R greater than or equal to 1. And again S of R. This is the number of ways of distributing R objects to R identical boxes. So each box must be non-empty. So every box will have exactly one object. So this can be done only in one way. So for R greater than or equal to 1, S of RR will be equal to 1. Next result is, so if you take S of R minus 1, that will be equal to RC2. So let us see how do we get S of R minus 1 equal to RC2. So this is the number of ways of distributing R objects to R minus 1 boxes. So each box must be non-empty. അപ്പോൾ നമുക്ക് R objects R minus 1 boxes ആണുള്ളത്. അപ്പം നമ്മൾ R minus 1 boxesലും ഓരോ object വെച്ച് place ചെയ്യും. ബാക്കി ഒരു object ആയിരിക്കും വരിക. Okay, so that object has to go to one of the boxes. അപ്പോൾ നമ്മൾ ചെയ്യേണ്ടത് ഇത്രയേ ഉള്ളൂ. So different number of distributions എന്ന് പറയുന്നത് ഒരു ബോക്സിൽ രണ്ട് object വരാം and all the remaining objects will be arranged in a single box. So those two objects can be distributed in RC2 ways. If total namukku R objects aanullathu, out of R you can choose two objects in RC2 ways. So fill those objects into one particular box. Now all the remaining objects will go to single boxes. So the required number of ways will be RC2. So let us write that. So there is one box which contains two objects and the rest of the boxes will contain one object. Hence, it is sufficient to find the number of ways of picking two objects and placing into a box while the remaining will go to identical boxes. So there are RC2 ways to do this. So therefore S of R minus 1 is equal to RC2. Next result is S of R minus 2 is equal to RC3 plus 3 RC4. Now here you have R objects and R minus 2 boxes. അപ്പോൾ ഇവിടെ നമുക്ക് എക്സ്ട്രാ ആയിട്ട് വരുന്നത് 2 ഓബ്ജക്ട്സ് ആണ്. അപ്പം ഓരോ ബോക്സിലും ഓരോ ഓബ്ജക്റ്റ് വെച്ച് ഫില്ല് ചെയ്യുക. സോ there will be remaining 2 objects. അപ്പോൾ here you have 2 different cases. അപ്പോൾ ബാക്കി 2 ഓബ്ജക്റ്റ് ഉണ്ട്. അപ്പോൾ ആ 2 ഓബ്ജക്റ്റും ഒരു ബോക്സിലേക്ക് തന്നെ പോവാം. സോ there is a case where you have 3 objects in one box and all the remaining boxes are one object. ഇനി വരുന്ന കേസ് എന്ന് പറയുന്നത് നമുക്ക് 2 ഓബ്ജക്റ്റ് ഉണ്ട്. 2 ഓബ്ജക്റ്റും ഓരോ ബോക്സുകളിലേക്ക് വീതം പോവാം. സോ there will be 2 boxes which contain 2 objects and all the remaining boxes will contain exactly 1 object. So those are the 2 possible cases. So now for each case we will see how many number of such distributions are there. So there are 2 extra objects to be placed. So there are 2 possible cases. So first is 3 objects in one box, and this can be distributed in, okay, നമ്മൾ previous problem ചെയ്ത പോലെ തന്നെ this can be distributed in ഒരു ബോക്സിൽ 3 ഓബ്ജക്റ്റ് പ്ലേസ് ചെയ്യണമെങ്കിൽ that can be done in RC3 ways. So this can be distributed in RC3 ways. Now the second is 2 objects in 2 boxes. Now when you have 2 objects in 2 boxes, so first let us pick all the 4 objects. അപ്പം നമ്മൾ 4 objectsനെ ആദ്യം ചൂസ് ചെയ്യുക. 4 objectsനെ നമുക്ക് RC4 വേസിൽ ചൂസ് ചെയ്യാം. അതിനെ 2 ആയിട്ട് എങ്ങനെ ഡിവൈഡ് ചെയ്യാവുന്നുള്ള നമ്പർ ഓഫ് വേസ് നോക്കുക. സോ ദാറ്റ് ഇസ് ദി റിക്വയർഡ് നമ്പർ ഓഫ് വേസ്. സോ ഫസ്റ്റ് there are RC4 ways to pick objects, and here you are having 4 objects. 4 objects have to be divided into 2 groups which contain 2 elements. So that will be equal to 1 by 2 factorial into 4C2 വരും. So നമ്മൾ ഓബ്ജക്ട്സ് 1 2 3 4 ആണെങ്കിൽ നമ്മൾ നേരത്തെ കണ്ടതാണ്. സോ when I choose take 4C2, 4C2ന്റെ അകത്ത് ഞാൻ 1 2 കൗണ്ട് ചെയ്യുന്നുണ്ട്, 3 4 കൗണ്ട് ചെയ്യുന്നുണ്ട്. എനിക്ക് ഇതില് പക്ഷെ ഒരു കൗണ്ട് മാത്രം മതി. കാരണം ഞാൻ 1 2 എടുക്കുകയാണെങ്കിൽ ഡിഫോൾട്ട് ആയിട്ട് അടുത്ത ബോക്സിൽ 3 4 ആയിരിക്കും വരുന്നത്. സോ യു നീഡ് ടു ഡിവൈഡ് ബൈ 1 by 2 factorial. So there are 1 by 2 factorial into 4C2, so which is equal to 3 ways to place them into 2 boxes of 2 objects each. So therefore there are 3 into RC4 ways. So now S of R minus 2 will be sum of these 2 cases. So that will be RC3 plus 3 RC4. So that is the required value.